formula. Now the structural formula attempts to draw the basic shape of a molecule. We can use ball and stick, space filling, or Lewis. Also, there is a condensed structural formula that you'll use in organic chemistry, which shows the carbon with the basic number of hydrogens bonded around it and any double or single or triple bonds that are involved. So these are the three that we're going to look at now. The ball and stick is the kind that you would use to represent what you see in the models. We would have the central atom being represented by the central bead. In this case, it's nitrogen, and that is why it's blue. And it's bonded with 3 fluorine, which are halogens, and they are all single bonds, and it's nitrogen trifluoride. The second one is the space filling, and you'd see that when you use any of your technology. A lot of your iPad apps and things like that would show space filling. It's a little bit more accurate. It shows you how the electron clouds actually interface with each other because they're covalently bonded, they're sharing. And the third one that we're going to look at today is the Lewis structure. In the Lewis structure, you would use dots for electrons and dashes for pairs of electrons that are bonded covalently. The first one we're going to look at is nitrogen trifluoride. This is the ball and stick model so that we can have something to reference, and we're going to draw the Lewis model. The first thing we do is we bring in the central atom. So the central atom is nitrogen. And then we draw the valence shell electrons around nitrogen. Nitrogen is in group 15, so it has 5 valence shell electrons. 1, 2, 3, 4, 5. Notice we've drawn 2 in the S and then 1 in each of the P's. And there are 3 places that another atom could bond. We're going to be bonding this with fluorine. And we would have 3 fluorines because fluorine is in group 17. So each fluorine atom has 7 valence shell electrons. They only need 1 more. And so we would draw in the valence shell electrons for fluorine. 1, 2, 3, 4, 5, 6, 7. So fluorine has 7. 1, 2, 3, 4, 5, 6, 7. And the last fluorine has 7. 1, 2, 3, 4, 5, 6, 7. And here we can see that each atom now fulfills the octet rule. They each have 8 electrons in their valence shell, so they're all sharing and they're all satisfied. So now let's draw the Lewis structure for this nitrogen trifluoride. Again, we draw the central atom. So we have nitrogen, and we're going to bring in the 3 fluorine. Each fluorine shares 1 electron, 1 pair of electrons with nitrogen. So we're going to use dashes. So this is bonded, this is bonded, and this is bonded. And then we just fill in for the electrons that are left. So nitrogen has 1 lone pair on this side, and fluorine has 3 lone pairs, making a total of 6 electrons that are not shared. Lone pairs mean that they're not shared. So we just draw those in. So again, it has 1, 2, 3, 4 pairs for nitrogen. That would make 8 electrons. 1, 2, 3, 4 pairs for each of the fluorine. Again, 8 electrons. Now let's look at the next compound. This is ethene. It is an organic molecule, but it's drawn the same way. The first thing we want to do is bring in our central atoms, and our central atoms are the carbon. There are 2 carbon. And then the next thing we want to do is draw in the valence shell electrons. Now carbon is normally black, but just so that you're not confused, I want to use a different color for the valence shell electrons so that we don't get confused. 1, 2, 3, 4. And then the other carbon we'll use blue. So we see how these are bonded. 1, 2, 3, 4. And then we're going to bring in the hydrogen. Each hydrogen wants 1 electron. So we'll bring those in. And we'll use green. I guess not. Use blue. So here we see that the carbons are sharing 1 pair. Each hydrogen now is satisfied with its pair. But we have 1 single set up here of electrons. So these 2 electrons will share, the 2 atoms will share these 2 electrons, and it'll be a pi bond. It'll be wrapped around, and that's how we get the second bond here. So the first one was the sigma bond, and that would be these 2 electrons right here. And then the second bond is the pi bond, which is right here. So now it's a little bit nice and neat if we do the Lewis structure. So let's bring in the Lewis structure for this one. And we see that we have the 2 carbons, and they share a double bond. So we're going to write in the double bond. And then we bring in the hydrogen. Each hydrogen has a bond, each of the carbons. Be able to see the black a little bit better. Now hydrogen only has the S to fill, so it only wants 2 electrons. So each hydrogen is satisfied with a pair of electrons. And the carbon then fulfills the octet rule. 1, 2, 3, 4. 1, 2, 3, 4 pairs of electrons. So with ethene, it also is covalently bonded, and you can draw the Lewis structure like this using only dashes because all the valence shell electrons are paired. Now the last example is going to be carbon disulfide, and again here's our ball and stick model, and we're going to start with our central atom, which is carbon. So carbon is our central atom. Carbon has 4 valence shell electrons. 1, 2, 3, 4. And each sulfur wants 2. So I'm going to bring sulfur over. Sulfur normally is yellow in the diagram, but it's a little hard to see yellow. So I'm going to use the purple again. And we're going to draw the 6 for sulfur. 1, 2, 3, 4, 5, 6, and in this one, 1, 2, 3, 4, 5, 6. So each sulfur has 6 electrons. Now let's see how they share. Well, the sigma bond is easy because the sigma bond is right here. The pi bond is a little bit more difficult. We still have a pair that's not shared, so these 2 would be shared, and then these 2. Notice that the pi bond wraps around. Oops, right over my dot. The pi bond wraps around that. Make it dark again. And we have 2 pairs of shared electrons for each of the sulfurs, with the carbon being the central atom. Now we're going to go ahead and write that as a Lewis structure. Here's our central atom, carbon. Here's sulfur and sulfur. They share 2 pairs, so it's a double bond. So we write in our double bond, and then we fill in for the lone pairs. Carbon does not have any lone pairs. It has its 8 shared pairs. And sulfur has 1, 2, 3, 4 electrons that are not shared, so it has 2 lone pairs, and this sulfur has 2 lone pairs as well. So our Lewis structure would include 4 dashes and then 4 lone pairs. I hope this helps you understand how to draw Lewis structure. You always start with the central atom, and you're going to note the number of valence shell electrons in each element present. Have a great day.